Hello viewers, today we are going to talk about what is air conditioning. This is the first video of this channel. We're gonna go over some basic stuff, and there is more videos coming up and regarding electricals, components, airflow, and other stuff. If you're interested, you just follow up. And the next videos then is gonna come up. So in case you're wondering who I am, here we go. You can see me right up there. My hands is right next to it, is cut off and floating in the air. And we got a little bottle of H2O. Now we're gonna learn what the air conditioning is in like 5 seconds. Here we go. We got a spray bottle, we got the hand. We're gonna do this a little bit and then move, and here we go. That's pretty much the basic air conditioning. Congratulations, now you know what air conditioning is. Let me put this bottle away. And we're gonna go over what just happened. We sprayed some liquid over my hand, and I moved my hand in the air, and my hand started cooling down. Now pretty much this is what happens in the air conditioning. The only difference is everything is controlled. Over here we had some water wasted to cool my hand down for no reason. So we removed heat out of my hand, and how we did do that, when I spray my hand with water and I start moving my hand, the water that was over my hand, it start getting evaporated. And for that to happen, that water need to remove heat out of something to change state of liquid to vapor, and that something was my hand right there, and that's how we dropped the temperature. So we removed heat. There was less heat on my hand after I did that. There is no such a thing as cold, by the way. I mean, just put that in here. I don't know why I did that, but yes, either there is heat, there is less heat, or there is no heat. Now, no heat scenario is kind of impossible. You cannot get that cold on the planet Earth. In the space, you may get lucky and you really get close to that number, but again, it's impossible. No heat scenario is called absolute zero, which is over negative 450 degree Fahrenheit. So it's pretty darn cold. Yeah, I don't know even why someone want to know how cold it is, but it's just to let you know, it's pretty damn cold. Now, how air conditioning works, pretty much the same thing happened up there, but it is controlled. So we're not wasting any water, we're not just cooling your hand only, just up here. We're cooling my head at the same time with everything else around me. We have refrigerant in a closed loop system. Imagine every one of these lines that I drew over here are representing a copper line or a pipe, as you say. This is our compressor. It's going to create a pressure differential. Low pressure comes in, it get compressed, it get pushed out into a condensing coil. Out of that high pressure gas passes through condensing coil, it's gonna turn to liquid. It goes to a metering device. It could be a TXV, EEV, piston, cap tube, doesn't matter, whatever. But it's gonna be going into a metering device as a liquid It's just gonna, from high pressure is gonna be low pressure. It's not gonna be complete liquid, but we call it liquid for easier learning process. And that liquid, it comes into an evaporator coil, which is always going to be inside of where you try and condition the air, either inside the house, inside the freezer, inside the cooler. This is on the inside of the device. That low pressure comes in, it goes inside the evaporator coil, air passes through in between the fins, and that liquid is going to turn to vapor, and it goes back to the compressor. Now, quite a few things happening in this scenario. The high pressure liquid, we're going to start from here this time, not here. High pressure liquid, it comes into the metering device. The metering device will control how much refrigerant has to pass through for our system to work properly. Now, the liquid that it passes through is not complete liquid anymore. It is going to be a saturated liquid. What is a saturated liquid? It's a liquid that actually is a mixture of gas and liquid at the same time. It is just ready either to be turned back to liquid by removing heat out of it, or is ready to turn to gas if we add heat into it. We have a saturated liquid coming out, goes into the evaporator coil. Now that liquid gonna start boiling off inside these tubes. To do that, that liquid need heat. If you don't add any heat into that liquid, this coil is gonna freeze up very quickly. So what happens is that liquid comes in, air is gonna pass through the coil, and the heat that is required to turn this liquid into gas, it comes in from the hot air that is passing through the coil. As it does that, the hot air into the coil is going to get cooled, and it comes out from the other side of the coil and is going to go where is matter to us. Now that liquid is turned to gas, it's going to travel into the compressor. Compressor will compress that gas again, push it out as a very hot gas into a condensing coil. And the condensing coil is gonna remove the heat out of that hot gas, and is gonna turn it back to liquid. That's why it's called condenser. It's gonna turn vapor to liquid. That's why it's called evaporator coil, because it's gonna turn liquid to vapor. This process keep happening till your thermostat satisfies, or one of the major components break down and the cycle stops. That's how air conditioning works pretty much. You remove the heat out of the area that it's matter to you, like inside your house, inside your freezer, inside your refrigerator, or whatever the case might be. You remove the heat out of that area, you transfer the heat into outside where it doesn't matter to you, and you're gonna dump it in there. You remove the heat from your house, dump it outside, everyone's happy. Pretty much the same principle in your car, in the walk-in freezer, walk-in cooler, a mini air conditioning, a big air conditioning, chiller, doesn't matter. Everyone follow this procedure. Now, we're gonna have quite a few terminologies in this area that we're going to be using. One of them is called subcool, and the other one called superheat. As I mentioned earlier, there is going to be a saturated liquid passing the metering device. It is a liquid mixed with gas at the same time. It is just ready to either turn to vapor or back to liquid. Depend if you add in temperature, you're adding heat into it, it's going to turn to vapor. You remove heat out of it, it's going to turn to liquid. This is called saturated liquid. The more heat you add to this liquid, the faster it will turn to gas. And as soon as it turns to gas, your superheat starts. So somewhere down all the way at the end of this evaporator coil with the system that is working properly, you're not gonna have any more liquid left. And anything past that is just gonna be gas only. And it goes back to the compressor. Now, the more heat you add into that liquid, the higher your superheat is going to be. That's called superheated gas. If you touch that line, which is a suction line of the system, to our sense, it is cold, but that's a superheated gas because it's past its boiling point at that pressure. And superheat is most of the residential air conditioning. They're looking somewhere between 8 to 12 degree is a perfect superheat range. Same thing for the subcooling, 8 to 12. That's a perfect range, but it could be different on the system designs, compressors, or the way the system is, the metering device. Those numbers could be vary. Same thing, subcooling happening over here as well. Now, when the very hot vapor, superheated vapor, so superheated vapor comes in, it's not very superheated, but it is at some point. And since the compressor is compressing that gas, the vapor then it comes out of it, it's even more superheated. So very high pressure, high superheated gas comes out of the compressor and it goes through the condensing coil. When you remove heat out of that refrigerant, somewhere down here, I would say 75-80% pass through the coil. That refrigerant is gonna turn to liquid. And when it comes out of this condenser, it's gonna be a liquid. Now, any more heat you remove out of this refrigerant that is flowing or pressure drop take place when this refrigerant is flowing, you're gonna start adding subcooling to that refrigerant. These are very important numbers that we're gonna have to have cross a system for a system to work properly. So we're gonna have subcool right over here at the end of our condensing system. We're gonna have superheat at the end of our evaporator coil. So these two ends gonna have these two. Then at the outlet of our compressor, we have superheated gas again. So we're gonna read superheat in two different areas of the system. Subcool, we only read it at one area of the unit. This is a basic air conditioning. That's how it's designed, how it works. Pressure and temperature, they always work together. The higher the pressure, the higher the temperature. The lower the pressure, the lower the temperature, or the other way around. That if you drop the temperature, you remove heat, the pressure will get reduced. And if you add heat, increase the temperature, your pressure will go higher. Now, how much energy do we need to make this happen? This is something that we're gonna calculate with BTU. What is BTU stand for is a British thermal unit. Now, all these calculation and numbers is based on ice and water to get those numbers out. How much is 1 BTU? How much energy is it? 1 BTU is equal to 1 degree change in 1 pound of water. So if you have 1 pound of water and you increase the temperature by 1 degree, you just used 1 BTU to do that, or the other way around. If you remove 1 degree out of 1 pound of water, you just wasted 1 BTU. Every 12,000 BTU is count as 1 ton. That's a little bit ice related. I mean, I really don't want to get into that, but 12,000 BTU, 1 ton of ice in 24 hours. What does that mean is you can have ice at 32 degree, you can have water at 32 degree. Now, if you have a ton of ice at 32 degree, it will require 12,000 BTU to make that ice to 32 degree water. The temperature has not changed. It just the state has been changed from ice to liquid. That's called latent heat. Sensible heat is the heat that we can sense with our body. We can put it on the paper, we can show it, we can do all of that. Your thermostat gonna show you're gonna show the sensible heat. But latent heat, which is very important in any refrigeration system, that's what it is. You have 32 degree ice, a ton of it. Not a ton, 12,000, 2,000 pounds with a ton, metric, of course. Now, you require 12,000 BTU to make that ice just liquid. You haven't changed the temperature at all. You just changed the state of ice to liquid. But up here you see for every degree that you're changing, you're using 1 BTU. This is sensible heat. This is latent heat. Again, I really don't want to dig into it too far, but that's what it is. So 12,000 BTU is 1 ton. If you have a house then it has a 5-ton air conditioning on it, that means it has a 60,000 BTU capacity cooling. That's called 5 ton. If it's a 4 ton, it's going to be 48, 3 ton, 36. Of course, just go on. Now, every 3.41 BTU, it's 1 watt. That's how much energy you need to make this happen. If you have 3 pounds of water, you're going to be using 1 watt to raise the temperature 3.41 degree. Now, in the refrigeration system, like freezers, coolers, stuff like that, they don't use BTUs. They use in horsepower for system ratings. That's the only reason that I put it down here. I mean, that's a good thing to remember by, but that's what it is. Every ton of cooling is 4.71 horsepower. That's mainly used in refrigeration. That's used in air conditionings. This is it for today. If you have any question or comment, put it down below. We will be going over other stuff like airflow, electrical components, and pretty much everything else involved in the air conditioning and refrigeration in our next videos. But this is for today. Thank you.